Lesson 8.3 has us graphing the entire quadratic, ax squared plus bx plus c. We now have all three values. All right? So, what do these numbers currently mean to us? Well, b doesn't mean a whole lot. C doesn't mean a whole lot. They do affect our graph, and we can predict how they're going to affect it, but they're not directly useful to us right now. The nice thing is A is still the stretch. So remember, stretch means how much times taller or skinnier it gets. So, if this is my normal function, this would be a stretch, and this would be a compression or a shrink. Our book's been calling it a shrink. Compression's another name for it. So this would be a shrink. All right, so A still tells us that, and its number is very specific about how much it stretches or shrinks by. So it's going to be a short lesson, but there's a lot to cover in one individual problem. So the primary new thing for today is the axis of symmetry. For our last couple classes, it was always x equals 0. That's not the case anymore. X equals 0 was only when we didn't have a b value. So the axis of symmetry formula comes from the quadratic formula, which we don't really know right now. So this isn't my favorite ordering to teach this in, but this is a simpler equation to use. But this does come from somewhere. We'll find out about that in chapter 9. This finds our folding point, the dashed line that our graph could fold over itself. So in a quadratic, that halfway line is called the axis of symmetry. And when we find that, it's going to help us start our table, because we're not just going to use -2, -1, 0, 1, 2 anymore. We're going to have a different set of numbers to use based on the axis of symmetry. So let's look at our first actual graph. All right, we got a couple strategies here. Our graph has an a value of 2, a b value of 8, and a c value of -1. The axis of symmetry is going to be that equation we were using, -b over 2a, and this is going to find the middle of our graph. So as soon as I find this, I'm going to put a dashed line somewhere on here. All right, so I got -b, my b is 8, over 2a, my a is 2. 2 times 2 is 4, so it's -8 over 4. -8 over 4 is just -2. So x equals -2. All right, that's going to be this line on my graph. So I'm going to put a dashed line here. This is where mine should fold over. This is the axis of symmetry. X equals -2. All right? So now we're set up to use our strategy for filling out a table. All right, this is going to be new. But the nice thing is it relies on something we hopefully already know. All right, let's make our table here. And the axis of symmetry goes in the middle, -2. And then we go up and down 2 numbers. So a little side note here, axis of symmetry goes in the middle. All right, so that means everything's going to be symmetric. So once I figure out these 2 numbers, they're going to match these 2 numbers. Makes life way faster and easier for us. The last thing I'm going to write down here is my pattern from the parent function. All right, I know the parent function doesn't line up around -2, but this is going to be the vertex for each function. And ours changes in a similar way. So It's just going to be helpful to have there for us. So now we need to find one point on our graph. We're going to go for the vertex, which means I got to plug -2 into my equation. All right, so I got 2 times x squared plus 8 times x minus 1. And everywhere I had an x, I'm going to plug -2 in. -2 squared is 4. This comes out to 2 times 4. 8 times -2, that's minus 16, minus 1. So now I got 2 times 4 is 8. 8 minus 16 minus 1. That comes out to -9. So my vertex is at -2, comma -9. 2, 3, 4, 5, 6, 7, 8, 9. So that's my vertex. All right, now we don't have to do this again. We only had to do it one time. Now what we get to do is use our pattern from the parent function. So the parent function went up 1 here, but we have a stretch of 2, which means our change is going to be twice as much. So instead of +1, I'm going to go up +2. -9 plus 2 is -7. From 1 to 4, the parent function goes up +3. We double that, so we go up 6. -7 plus 6 is -1. And then these copy over here. All right, so this is the weird part. This is where you just have to trust that the pattern is supposed to be the same. Parabolas have really similar shaped graphs, but since ours has an a value of 2, this is still the stretch number. That's why I said that stretch still works. So if we plot these points, it's going to look real nice. -1, comma -7. It's going to be right here. -2, -3, -7 is going to be right there. Then 0, -1, -4, -1. So nice U-shaped graph. All right. This is probably the hardest part to learn, is how this pattern turns into this pattern. So pattern, and then pattern times stretch. That's why we don't have to plug in any extra numbers, is because we can follow the pattern. We just have to respect the stretch from our a value. So it's a weird problem. It's a long problem. But let's do another one, and then we'll talk about some other things that we might be asked about a quadratic graph. Here we go. Let's identify our a, b, and c values. A is 3, b is -6, c is 5. Axis of symmetry is going to be -b, which is -6. These two negatives are going to cancel, over 2 times a. That's 2 times 3. This comes out to 6 over 6, or just 1. So our axis of symmetry is going to be at x equals 1. Right about here. It's going to be our halfway point again. AOS, x equals 1. All right. So this is always going to be our starting point, so we can figure out where to start our graph. Now I'm going to make a table, and centered around my axis of symmetry. I can choose any 5 points, but these 5 make the nicest shape on the graph. So 1 is in the middle, and then 2, 3, 0, -1. So I always have 5 values centered around my axis of symmetry. Now I'm going to write down the parent function just as a reference for myself. Always suggest doing this. Now we just have to figure out one value to start with. We're going to do our axis of symmetry, f of 1, 3 times 1 squared, minus 6 times 1, plus 5. That comes out to 3 minus 6 plus 5. Negative 3 plus 5 is positive 2. So my vertex is 1, 2. Vertex. All right, now we're going to compare to our parent function, but we do the pattern times 3. Because our stretch is 3 from our a value. So this pattern goes up 1. Well, 3 times 1 is 3, so I'm going to go up 3. 2 goes to 5. And then 1 to 4, that's plus 3. I do 3 times that, so I'm doing plus 9. That's 14. Not even going to be able to get that point on the graph. But these reflect over to this side because it's symmetric, so it saves us a good chunk of time and effort. So let's plot all these points, 0, 5, 2, 5, and then 14 is going to be a little bit above the graph. I don't even know if it'll be on the camera. Oh yeah, just barely. Perfect, just barely. So nice and steep because it's got a stretch of 3. That was kind of an ugly line, but bear with me. It's supposed to be U-shaped. Markers aren't the most accurate drawing utensil. All right, so the extra things we can ask ourselves now. Do we have a maximum or a minimum value? So let me erase some of my work here so I have some room to write. We can be asked if we have a max or a min. Should be pretty obvious. If we've got the bottom of the bowl, that's a minimum value. If we have the top of a mountain, that's a maximum value. So ours has a minimum. Our minimum is our vertex. The min or the max will always be your vertex because that's the turning point as we described it at 1, 2. Then domain, if you recall, is always all real numbers. Because what does domain mean? Domain is all the possible x values. Well, I can use any x value I want. I'm allowed to square any number, so that's why domain is all reals, is there's nothing I'm not allowed to use. And then range is all my possible y values. That's what the vertex helps us with. So I'm all of the numbers from here up. So from 2 up. Y is greater than or equal to 2. Now if it's the mountain, I'm going to turn that to less than or equal to because it's a maximum, which means I'm all the numbers at the top of the mountain and below. So these are a couple of the things we can be asked about our function. Where's our minimum or maximum value? What's the domain? Always going to be all real numbers. And then what's the range? Our vertex helps us answer the range question. All right, I'll do a lot more practice in class, but hopefully this got the strategy down. Pay closest attention to how the parent pattern is used.